Hello everyone, my name is Jeffrey Edgecombe and I will be presenting this evening the Breakfast analysis on how does the amount of sugar-sweetened beverages consumed affect subpopulations of New York. Just a little bit of background, obesity in adults is defined as having a BMI which is 30 or higher. And there are three classes of obesity, class 1, 2, and 3, as you can see on the screen. According to the CDC, sugar-sweetened beverages, or SSBs, are sugary drinks, basically, that are the leading source of added sugars in the American diet. 27.6% of New York residents were obese, according to the census in 2018. The aim of this analysis is to discover if sugar-sweetened beverage consumption is related to obesity rates and increased BMI within different subpopulations of New York residents. Just a few methods right now. The breakfast data, the data in this analysis was collected by the Behavioral Risk Factor Surveillance System, otherwise known as breakfast. Breakfast collects data regarding a person's health-related risk behaviors and events, chronic health conditions, and use of preventative services. The data we used for this analysis was from 2016. A subsample of the 2016 breakfast data was created, which we restricted the population to New York residents only. 10 different variables were created and analyzed, and those are listed below, with the main variables as number 1 being the number of sugar-sweetened beverages consumed per week, and other ones which we'll go over later in the analysis. Methods continued. The data cleaning process. Creation of the include variable was done first. Then a crude and adjusted regression was run. These regression models were run for all variables with include equaling 1. Assumptions were okay after these were run. The regression models were rerun, checked again, and they were still okay. Linearity was assessed for BMI and age. Following that, a component plus residual plot, or CPR plot, was then created. This involved all variables listed in the last slide, 1 through 10. The residuals were then plotted against the predicted values in order to assess equal variance. After equal variance was assessed, normality of the data was then assessed using a QQ plot. And the software we used was a Stata IC16 64-bit software. The results. Now, these tables are a little small, and I realize that, and I apologize. But after analysis, these tables were produced. In Table 1, participants' characteristics by weight status was produced, and in Table 2, association of BMI with sugar-sweetened beverage consumption, adjusted and unadjusted linear regression is shown. Now, it's not typical to run an unadjusted regression with every covariant, so that is why there's multiple dash marks in the unadjusted column. And it's just kind of common to run the exposure of interest, which in this case is sugar-sweetened beverages. As you can see in the far right column of Table 2, there are p-values. The p-values that are in yellow are the statistically significant p-values. That means anything less than 0.05. Oh, sorry, just to go back to that slide. I'd just like to mention that you never want to put a p-value of 0 on any statistical analysis, which is why there's p-values less than 0.001. Okay. Results. Some key findings as seen in tables 1 and 2. All findings, as mentioned before, with the p-value less than 0.05 are considered to be statistically significant findings. So, our covariant in question, sugar-sweetened beverage consumption, was the main one. The amount of sugar-sweetened beverages consumed had significant impacts on BMI, specifically in the categories of 0 to 1 drinks per week and over 7 drinks per week. Race also had statistically significant data produced, specifically in Black and Other, which both produced p-values less than 0.001. And lastly, education level, as seen in Table 1, 36% of the population had graduated high school or less, but 43% of that population was obese or worse. Conclusion. The findings presented in this analysis suggest the amount of sugar-sweetened beverages consumed per week affects different subpopulations of New York in diverse ways in regard to their BMI. The main statistically significant findings include sugar-sweetened beverage consumption, education level, race, physical activity, and ethnicity, all being negatively affected in terms of BMI. Proposed intervention number 1. In New York City public schools, 74.6% of these students are Black or Hispanic, and with less than 10% being white. This statistic can be used to help target younger adults and provide a tailored health education class with specific concentration on BMI, diet, and obesity education. Since the Black and Hispanic populations are at the highest risk as seen in this study, this method will encompass the most vulnerable in hopes in decreasing the obesity rate in New York residents. Proposed intervention number 2. The absence of physical activity in New York population surveyed for this data is directly related to increased BMI. Since the majority of New York's population lives in the city, I suggest a citywide day of health, or basically an activity day, be organized every week in a local setting such as Central Park or another grassy area where multiple people can meet and spread out, especially in terms of COVID nowadays. In this day of health, instructors will promote movement and physical fitness, and they can either volunteer or be employed, and local healthy food vendors would be encouraged to attend. By doing this, the amount of physical activity theoretically would increase across the city, therefore decreasing sedentary behaviors, which is associated with increased BMI and obesity. And here are my references. Thank you everyone for listening, and I can't wait to watch yours. Thank you. Bye-bye.